Okay, finding a particular solution. What that entails is integrating f prime, because that's going to give us f of x, but when we integrate with indefinite integration, it's going to give us a plus c. Particular solution means finding out that value of c using this initial condition here. So, integrate, we get the integral of the derivative of f is just equal to f. The integral of the square root of x, or x to the 1/2, is 2/3 x to the 3/2 plus c. Now in order to find the value of c, we have to know a value for x and f of x, which we have here. Here's x, and that's f of x. So plugging in those values, 4 equals 2/3 times 9 to the 3/2 plus c. 9 to the 3/2, well, the square root of 9 is 3. 3 cubed is 27. And 27 divided by this 3 is 9. 9 times 2 is 18. So that turns into 18 plus c. So c equals negative 14. So the particular solution is 2/3 x to the 3/2 minus 14. Okay, marginals. We've got dc over dx. That's the rate of change of cost over units. That's a typo. When x equals 225, the cost is $1,136. Find the cost of catering to 500 people. So given dc dx, we need to find c, what we're trying to find. So c is equal to the integral of dc, which is equal to the integral of 5x over the square root of x squared plus 1,000 dx. So if we do a u substitution here with our inside function, then du is equal to 2x dx. Now we've got the x dx, but there should be a 2. So I'm going to move this 5, put a 2 there, divide by the 2. So now we've got the 2x dx. So this becomes 5/2 times the integral of du over the square root of u. Now, square root of u is u to the 1/2, and I'm going to move it up to the front, up to the top of the fraction by giving it a negative exponent. So this can be written as u to the negative 1/2 du. So the integral of u to the negative 1/2 is u to the positive 1/2 multiplied by 2, and the 2's would cancel. So it's 5 times x squared plus 1,000 to the 1/2 plus c. So right now we have cost is equal to 5 times x squared plus 1,000 to the 1/2 plus c. C for the constant of integration. This is not c for cost. And that's what we need to try to find right now, is what is that constant of integration. So we have to use initial condition. It's like we just did here in question 7, or sorry, in question 13. So the cost is $1,136.06 when x equals 225. Now it turns out that this right here, 225 squared plus 1,000, square root of that multiplied by 5 is equal to 1,136.06. So that means that C has a value of 0. So our cost function is 5 times x squared plus 1,000 to the power of 1/2. That's how much it costs to serve X amount of people. So the question is asking how much does it cost to cater 500 people. So you plug in 500 for X. Plug in 500 there squared, add 1,000, take the square root, multiply it by 5. That'll get you the answer there. It's about $2,505 to cater 500 people, according to that model.
Okay, question 14. You have been provided with these two equations. I've given you a picture of what the graph looks like, just so we can make reference to it. But the directions are to find the area bounded by the two graphs. Bounded means find areas like this one here. It's completely bounded by two graphs, and then there's this area right there. So we need to find the combination of the two areas. So what goes into this problem is finding these intersection points here, here, and here. Because the intersection points are going to give us the bounds of integration. There's going to be two integrals here. We've got to do an integral for this area, and we've got to add that to an integral to find this area. So the way you find intersection points of two graphs is to set the equations equal to each other. Get all the terms onto the left side and set it equal to 0. Factor out an x. And we get that, well, continue to factor. X plus 2 and x minus 1, so we get three intersection points, x equals 0, x equals -2, and x equals +1, which seems to coincide with our picture here. So the first integral is going to be an integral from -2 to 0, and then we're going to have to add that to an integral from 0 to 1. Now the question is going to be, and it's obvious with the graph, but you won't have the graph. The question is, if I call this y1 and y2, between -2 and 0, which one's the upper function? So if I outline in blue, between -2 and 0, the blue function is above, and the red function is beneath. But between 0 and 1, the red function is above, and the blue function is beneath. Visually, we can see that on the graph. What you're going to have to do algebraically, since you don't have the graph, is in this interval 0 to -2, choose a test point, plug it into both functions to see which one yields the higher value. So if I choose -1, -1 cubed is -1, minus 4 times -1, that's +4, so that gives us a value of 3. In this equation, -1 squared is 1 times negative is -1, plus 2, that's 1. So this one right here yields the greater value with a test point between 0 and -2. So this is the above function in that interval. So we start with x to the third minus 4x, and then we subtract the other function, -x squared minus 2x dx. And we add from 0 to 1. And again, we can clearly see that from 0 to 1, the red function, or y2 is the above function. But still, we need to show that algebraically since you're not going to have the graph. So choose a value between 0 and 1, like 1/2. 1/2 to the third power is 1/8, minus 4 times 1/2, so it's minus 2. Here, in this one, if we plug in a 1/2, negative 1/2, or 1/2 squared is 1/4, times negative is negative 1/4, minus 2 times 1/2, so that's minus 1. So this right here is negative 5/4. This simplifies to negative 15/8. This one's more negative, so this one has a higher value. So this is the above function now, negative x squared minus 2x, subtracting the lower function of x to the third minus 4x dx. Now, simplifying and combining some like terms, the integral from negative 2 to 0 of x to the third plus x squared minus a negative becomes plus 2x and a negative 4x. That's negative 2x. And then we're adding the integral from 0 to 1 of negative x to the third minus x squared plus 2x dx. So this one here has an antiderivative of x to the 4th over 4 plus x to the third over 3 minus x squared, and we evaluate that between negative 2 and 0. That gives us 0 minus, remember we do the upper bound into the antiderivative first. If all of the x's are 0, we get 0. Now plug in the lower bound. We're going to get negative 16. Well, actually, negative 2 to the 4th power is 16. 16 over 4 is 4. Negative 2 cubed is negative 8, so that's negative 8 thirds, and then negative 2 squared is 4, so that's minus 4. Plus 4 minus 4 cancel. Negative times a negative is a positive, so it equals 8 thirds. Now this one here, this antiderivative is going to be negative x to the 4 over 4 minus x to the third over 3 plus x squared evaluated from 0 to 1. So when we plug 1 into the upper bound, we're going to get negative 1 fourth minus 1 third plus 1. That's the antiderivative, the upper bound, minus the antiderivative at 0. That's just 0. So putting everything in terms of twelfths, negative 1/4 is the same as negative 3 twelfths. Negative 1/3 or minus 1/3, that's the same as 4 twelfths. And this is 12 twelfths. So we've got negative 3 twelfths minus 4 twelfths, that's negative 7 twelfths. Plus 12 twelfths, that's 5 twelfths. So 5 twelfths. So now I can take these two areas, 8 thirds plus 5 twelfths. 8 thirds, if we want to make that in terms of twelfths, is 32 twelfths. So final answer is 37 twelfths for the area.